So the next question that we've got here is question number 3. Let's go back here and let's change the transparency so we can actually see what's going on. Which of the following investment options would you recommend for Cheryl, who has $14,000 to invest for 5 years? Show all you're working for A, B, and C. Remember which formula, then we substitute and then we solve. Now here it clearly states simple interest, so let's just use the simple interest for this one. I equals P, R, and T. And now let's pull out all the information that we need. So T equals 5 years, I believe. That's what it says in the top there. 5 years. Okay, long time. Our rate happens to be 6.5%, which is also 0.065 as a decimal, and we have our P. Our principal is $14,000. That's not bad. And now we have all our 3 inputs to find our interest. Now, second step is substitution. So our interest rate happens to be $14,000 times 0.065 times 5 years. So our interest is, let's ask our calculator. So we got 14,000 times 0.065 times 5 years, and so our interest happens to be $4,550, and let's just add those together so we actually can compare that to the compounding ones, because remember, with the compound formula we get actually the balance. So let's go back here and grab the 14, make sure that we are adding rather than multiplying, and we add our interest, which then becomes 18,550. So in our new balance is $18,550. So after 5 years, that's what she's having. Let's do the next question. So the next question obviously tells us that we use now 6.5%, so same interest rate, but this time it's compounded quarterly. So the magic word obviously is compounded. Let's go back here. And we can move this, I believe. Yes, we can. So we leave that up there. Compound interest. Now, according to the internet, with the compound interest formula is A equals P multiplied by itself plus I to the power of n. Okay, let's do that. Go back here. So, compound interest, it says it here clearly, so we need our balance, A, the amount, in our bank account is the same as the principal, which is always the same, multiplied by itself, times I, which happens to be the interest rate per interest-bearing period, to the power of the number of interest-bearing periods, okay? So let's show you 2 ways again. So the principal is always the same as $14,000. Our I is the same as 0.065 divided by 4, because there are 4 quarters in a year, and that is really annoying. And I is the interest rate per interest-bearing period. So if the interest-bearing period is 1 quarter, then it is a quarter of the annual interest rate. Okay, and the last one is N. So it goes on for 5 years, and there are 4 quarters in a year, which makes it then 20 compound-bearing interest periods. Okay, so N is the number of interest-bearing periods, and it's not paid out after the year, it is paid out after every quarter, and there are 4 quarters in a year, so there are 20 quarters in 5 years. So now let's write that down. So that is the which formula. Now we substitute. So the amount in our bank account after the investment is finished is our $14,000 interest rate multiplied by itself. We add our interest per period, which is a quarter of the annual interest rate, and we take that to the power of 20 quarters. And our calculator should give us a nice number for that one. So 14,000, we multiply that by 1 plus, remember it's the annual interest rate divided by 4, because there are 4 quarters in the year, multiplied by 5 years times 4 quarters, and that should give us a value of 19,325.88. 19,325.88. 19,325.88. And now it makes nice sense to have the principal plus the simple interest. Okay, so we get a little bit more money, and now we do the same with the monthly one. And I'm just well, I will not be as thorough, because it's identical to the top one, except that we exchange the 4 with the 12, because all of a sudden it's monthly and they're 12 months in a year. So let's do that quickly, move that up. So same idea as I said, all we do is we exchange our 4 with a 12. So so the account, the amount in our bank account after 5 years, so let's do that, is the same as the principal of 14,000 multiplied by itself to the power of, remember, 6.5%, it's consistently 6.5% over the entire question. This time it's compounded monthly, so if we want to find out what the 1/12 of the annual interest rate is, we divide it by 12, and then we take it to the power of 5 years multiplied by 12, which should be 60. And we also get a value for this one, and let's ask the calculator quickly what that is. So I said all we do is we exchange the 4 with the 12. So it's no longer quarter, it is now month. And we get 16,000, nope, divided by 12. It's a big number. I believe we are out of our, let's try that again, slightly too big, to the power of 5 years times 12 months. That's a bit more like it. So 19,359, 19,359 and 44 cents. Now remember that the question was which option is the best. So let's just change the transparency here and bring all this back. So let's show you. So that's one example. That's our first answer. That's our second answer. And that's our final answer. And the answer happens to be Brush size, let's do brush size. Oops, beautiful, beautiful, beautiful. Now, which one is the better option? Well, with regard to money, this one is the better option. Not much different to that one, but it is the better option. So this gives us the most money. So according to the question then is, which option is the best option? And the best option is C.